Hey everyone, welcome to Test 6 review. We're going to start with number 1. I'm going to go ahead in this video do all 6 problems for this problem, so you might just have to fast forward or rewind as you see fit. So let's get started. This is over negative exponents and simplifying, utilizing all of our rules. Let's take a look at a 5 to the negative 3. That would really be equal to 1 over 5 to the positive 3 times 25 over 1. You can simplify this even more and say that's 1 over 125 times 25. You could simplify before you divide or multiply across. So that'd be 1, 5, and your answer is 1 over 5. Suppose you don't want to go through all that hassle, and since there's no variables in this problem, you are welcome to stick it into your graphing calculator. You could see how I typed it in. You could hit enter. It does say that no decimals are allowed in this problem, so you do need to convert it back to a fraction, and you get 1/5. So let's move on to B. This one does have variables, so your calculator won't be able to help you out much, but notice there's no negative exponents here, so we just review our classic exponent rules. Notice that this has an external exponent of 3, so we need to do our expanded power rule. So everything gets raised to the 3, so that's 3x squared times 4 to the third power x3 times 3 power rule says if you have a power raised to another power, you multiply. So here we have 3x squared times 4 to the third power is 64x to the 9. Now it's just a bunch of multiplication, so we have 3 times 164, which would give me 192x. Add our exponents. 9 plus 2 would give me 11. That's called the product rule. And so we get 192x to the 11th. Let's go on to C. Have a good one. We have a 0 exponent. So anything raised to 0 power is really 1. So this whole thing times y to the negative 2. That's really like 1 times 1 over y squared, positive. Multiply across and you ultimately get 1 over y squared. Let's look at D. Again, we have exponent out to the side. We also have x to the negative 3. So you're welcome to move that x to the denominator if you want so that it becomes positive. Over here, on the other hand, this is really like saying x to the negative 1 and y to the negative 1, which really is like y over x to the 1 power each. Now we just look, 1 times y would just be y. We have y at the bottom, so we'll be able to address that in a minute. X cubed times x, that would give me x to the 4th. But because we have a y over y, my final answer just becomes 1 over x to the 4th. Okay, let's go on to E. Notice this is on the outside of parentheses, the negative 2, so that's really like 5 to the negative 2 and a to the negative 2. Over 5 squared a squared. And at first glance you're thinking, oh, I wonder if everything just cancels out. Not the case. This 5 to the negative 2 would go down to the denominator, so that would give you 5 squared times 5 squared. The same thing with a squared times a squared. So ultimately you end with 5 squared would be 25 times 25, which would be 1 over 625a to the 4th power. Ran out of space on that one. And our last one, a little bit more complicated, but that's okay. We could take it nice and slow. First, handle the power rule here, a negative 1 times a negative 3. So that would give me 4x to the 3rd power over 4 negative 2 times x to the positive 1. Now we can start cleaning it up a little bit. This 4 to the negative 2 would go up to the top, so that would be the numerator, 4x cubed times 4 squared all over x. 4 squared is really the same as 16, and 16 times 4 is 64. Then now notice we have x cubed over x, so that would just give me x squared, and that is my final answer.